Hey man, can you do me a favor and make sure this doesn't like fall? Hey, I want quiet. Everyone sit down in their chairs. We're gonna begin.
Wait, isn't it Monday and Thursday though?
Oh, we're changing it to Tuesday. It fits more people.
Tuesday and Thursday?
Yeah.
For every week now?
Yeah.
Not Monday?
Yeah.
Oh.
Hey, guys, quiet down. No one respect me? Quiet down. Okay. Everybody will begin right now. Today we'll do kind of a warm up. I call it odd or even. And we will. So if you want right now, pull up replit.com on your whatever is Chrome. Alright. Guys, stop talking. Stop talking. Thank you. Anyways, I know y'all are excited to see your friends, but we gotta continue, okay? Shut it. Get your hoodie out of your head, dude. Get your hoodie. Take off your hoodie, dude. It's like dress code. Wait. Okay. Alright, whatever. Let me make sure something. Can you adjust it? Yeah, that's good. Okay, so does everyone remember what this is?
Yes, sir.
This kind of thing where you're yeah, it's the main method. This is gonna be the main source of your code. This is gonna be where it's like the center of your code. It's gonna be where everything is. It's gonna be where all the I guess what Java is gonna be doing. So yeah. Today we'll be doing one lab. I kind of want to start off with a lab per kind of session. Yeah. Also, next week we'll start actually doing competitions and competing against each other. I know we've literally just learned Java for I guess 4 hours in total. But I suggest doing some outside practice outside of this, as well as I guess math. You learn a lot of math. So the prompt is first scan a number, and if it's even, print out this number is even, and if it's odd, print out this number is odd. You don't see that okay?
No.
It's not how you spell odd. Okay. You don't see that okay? So what do you think we should do right now? Yeah, scanner. So in order to take input, we have to use this thing called scanner. Right here. And in order to do it, you have to import it. Okay. Yeah, make sure you use the capital S and always use semicolons. Okay. So how do I create a scanner? There we go. What do you want to call it?
P.
Black.
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 We'll do black. We're not trying to be racist. No one's here. And what do you write after it?
White.
What's in parentheses?
There's a notebook paper.
What's in parentheses?
System dot in.
Why do you need notebook paper? I need a write one.
Sort out your notebook paper.
So,
Use your shirt.
right now, system.in stands for system input. So whatever you're going to write in your console, your black box, is going to be where you're going to do input. Got it? So, yeah. So what do I do next? So I want to check if the number is even or odd. And if it's even, I want to print that out. Okay, so what variable should I use?
In Kevin.
We'll do Kevin. Okay. should I get input as an integer?
You do those.
Shut up. I need someone else.
Whoa. Just tell me to shut up.
Okay. Since we have, it's not keyboard, since we have security black, it's going to be black right now. Okay. So whenever you use scanner and you want to take an input inside the console, which is the black box, you always got to use next or next whatever data type, right? If I want to take in double, how do I take in double?
Next double.
Exactly. The only exception to that is strings. Strings are a set of text, and we can use either next line, which gets the whole line, or just next. Just next. Got it? Okay, what should I do after that? Someone else. Thank you. What should I do after this? You don't know? Well, how do we check whether the number is even or odd?
If divided by 2. If
Okay.
statement.
If
You do remainder.
Shut.
I do like the mod
Okay,
thing.
Kevin.
Yeah.
So I'm not sure if y'all remember this, but we can use modulus. So modulus is essentially the remainder. So if 2 mod, or yeah, what we can do is we can mod to it. So if I had a number, like give me a number.
7.
7. If I mod the number by 2, so mod is this percent sign, it's going to give me the remainder after dividing it by 2, which would be what? So we notice if I have 6, which is an even number, and I mod it by 2, what does it give out?
0.
So that's the trick with even and odd numbers, right? If we mod it by 2, or divide it and take the remainder, if it's 0, that means it's even. If it's 1, that means it's odd. Got it? Stop playing around with the ball, chill. Got it? Everyone good? Okay. So how can we incorporate this knowledge into code?
You
There you go,
if
Kevin.
statement.
Yeah, an if statement. So an if statement, if you remember, is if condition, and then if the condition is true, I run the code below. Okay. So what should I put in this if statement?
Kevin,
F
modulus
divided
2
by
is equal
2.
to 0.
Percent 2 equals.
How do I equals to 0?
Equal.
2 equals. So if I want to compare 2 numbers on the left and right side, make sure to use 2 equal signs. Got it? So what happens if Kevin mod 2 equals 0? What do we know?
Then it's even.
Because when we divide it, that means there's no remainder. There's no remainder, that means even. So I can just say system, oh yeah. So remember, in order to output something, we use system.out.print. And we can just say even. So how do we count odds? What should we do?
Else.
Else. So else happens when the if statement is wrong. So if the if statement is false, the else statement runs. So what should we output here? Good. Remember, when you output, you always think of system.out number.
No, he never said anything about that. It's not my fault.
I just put odd. And remember the same.
Bro, you're so fast already.
Well, I have to so if you're like struggling with these concepts, I highly recommend looking online. Maybe look into if statements and scanner. Those are usually the most 2 complicated ones. But for now, this is kind of what we got, and I think it's pretty good. So yeah. So does anyone remember what strings are?
They're like a line.
A string is a string.
Yeah, string is
Containing characters. So a string is a group of text, right? A string is a group of text. So an example string would be string s equals to David. Right? String is essentially a group of characters. Yeah. So one thing to note is strings are indexed, meaning that they can be accessed in a sense. You'll notice. So each character or letter represents a digit. So D starts at 0, A is 1, 2, 3, 4. So when we do this, it's called zero-based indexing, right? Instead of starting from 1, we start from 0. Got it? There's no negative one. Yeah, Python, if you negative 1, I'm pretty sure you can.
The lowercase, it'll go backwards.
Okay, I see. Yeah. I think they also have like a step thing too. It's like you can also count by steps. So yeah. So if I extended this. Right. So how many letters or characters are in here? This has a space in between.
11.
11. It's not 10 because, actually no, yeah. It's not 10 because the space also counts as a letter. Or a character. It's characters. Yeah. So I'm going to go over a couple string functions. So just like math, string also has a bunch of functions that we can use and utilize. First thing I would like to say is char at. Char at. Oh yeah, by the way, if you want to pull up the notes, it's not mine. You can just check that out. So char at is I can pick any one of these indexes and then I can pick its value, right? So if I said s.char at 0, what do you think it would get?
Z.
Capital D. Okay. This, so whatever index is inside the parentheses you use, it outputs whatever you get out. So if I put in 3, what would I get out? Or return?
I.
Lowercase I.
Yes, because I corresponds to this. And remember, it starts 0 base. So it doesn't start like 1, 2, 3, 4. It starts 0, 1, 2, 3. Got it? So that's 0 base index. The char at will be pretty useful. But yeah, that's one of the most. So if I make another string, maybe call it T, and this time I'm going to use a lowercase d instead of an uppercase. Everything else is the same. They're just slightly different. Okay. So if I did s dot compared to,
False.
actually compared to does not give a Boolean
Equals
value.
to. It's equals to.
So compared to returns an integer actually. And so there's 3 possibilities. Whether the value is positive, 0, or negative. So if the value is positive, that means s is less than t, or lexicographically smaller. Lexicographically means like if you're searching up in a dictionary, the smaller one would come first, and then the second one will come second. That makes sense. If I had, I don't know, David and dinosaur. David comes lexicographically first. This is how you spell lexicographically. David comes first because A is earlier than I. Kind of like if you search it up in the dictionary, you'll see David first rather than dinosaur. So if it's positive, that means whatever this string is, I'm going to call this the calling string. That means the calling string is less than the receiving string. Got it? Now, if the value is 0, that means the calling string string is exactly the same thing as the receiving string for every single bit, right? And then if the calling string is negative, or if the value returns negative, that means the calling string is greater than. Okay? So if I did s dot compared to t and if I outputted it, what would it return? A positive 0 or negative value?
Wait, what happened?
If I outputted s dot compared to t with these two variables, it would be positive 0 or negative.
I think it would be, what'd you say?
If I compared s and t, would it return a positive 0 or negative value?
Say that again?
If I had two variables, s and t,
Yeah.
and I outputted s dot compared to t, would it give a positive or negative value? Yes, it would give positive. Actually, no, wait.
Yeah.
No, not positive.
I thought it was negative.
It would give negative. So, first things first, capital letters are treated greater than lowercase. Got it? Makes sense, right? Capital letters, blah, blah, blah. If you look at the ASCII table, I'm pretty sure capital letters come first. But, yeah. So if I had a more easier example, David and dinosaur, what would this output? Big guess.
What?
Oh, I thought you raised your hand.
No, I was gonna shoot this. Oh.
What would output? Nothing. So this would output, yeah, positive. Because A comes before I. So what it does is it checks all the numbers, and then once it sees like two different letters, it checks which is less or which is more. In this case, A is less than I. So, does it make sense or is it a little iffy?
Okay, so depending on what the receiving is less alphabetical than the not, or like the base, then it's negative.
Yeah.
Wait, so if it's a smaller number, wouldn't it be negative? Because like it's smaller, it's a bigger.
Wait, what do you mean smaller number?
It's like, I mean, it resembles a not.
Like, what compared to does is it calculates the differences for each letter, right? How do I explain this? Like,
The top one's more alphabetical, then it's positive. The
Yeah.
bottom one's more alphabetical, then it's negative. Yeah, if they're both the same word or very similar.
yeah. So when he means by more alphabetical, like I said earlier with the dictionary example, if I searched up David in the dictionary and dinosaur, which do you think is going to come first, David or dinosaur?
I mean, David.
David,
Dinosaur.
because we start from the left, and for every character that's equal, until we find like two different letters, yeah, or just like find the first difference in two letters and see which one is like.
Come on,
earlier.
there's no-
Since A is less than I, David would come first. Does that make sense? It's a little weird concept, but
I get it.
okay. I'll leave that to some thought.
So you take some trash.
Okay, so now we're just gonna do an easier one. This is gonna be string dot equals. So if you do s dot equals to t, it's actually going to give you some errors. Or actually, it sometimes works, sometimes doesn't. It depends what your string is. But you can't equals two strings. You have to use dot equals. And s dot equals t gives a true or false value whether s is exactly t. Got it? So will this return false or true? False. If I put David in uppercase, would it do false or true? False, because they're not exactly the same. Okay? These two strings have to be exactly the same in order for this to be true. Alright. So what if I wanted to count how many letters there are in this string? No, what we can use is the string function dot length. how it's formatted. There's nothing in the parentheses, but it returns an integer.
Hello.
And in this example, it would give out 5 because there are 5 characters inside. Does that make sense? And then finally, we have substring. So,
There's 2 types of substrings.
so a substring is a string that's part of it's a continuous string inside. So example of a substring would be David. Now what's not an example would be DVDZ. That's not. They have to be like continuous. Got it? So another substring could be like AZ or Zang or D space Z because they're basically like continuous. So that's what a substring is. So one string one string function we can use is .substring. Let's say I wanted to pull out Zang, right? What I can do is I can find the indexes, right? 7, 8, 10. And what I can do is I can put the starting string, or the starting index, which would be 6, if I want to pull Zang. And then I would put the ending index, which would be 10. Actually, wait. It's actually 11. What it does is this is the ending index plus 1. The reason for that is it includes all the letters from 6, but excludes the last one. So if you've seen this notation, it'll be kind of familiar, but yeah. So substring gives you a smaller string that's within the string, and it's continuous. What do you got? This? So this means it includes index 6, but it includes like 6, 7, 8, 9, 10, but it doesn't include 11. It excludes it. What do you mean opposite? So if I did parentheses 6 of 11, it would exclude 6, but it would keep on going to 11. So it'd be 7, 8, 9, 10, 11.
Okay.
So whatever parentheses it is, it doesn't have it. But everything, it just gives you a range of numbers. Yeah. Substring's a little weird. I think I explained it a little more. But the concept is it's a string within a string. Yeah, it's a continuous string. But in order to get it, you get the first starting or index, which is 6, and then you get the last index you want, which is 10, and then add 1.
How do you
Got it?
calculate?
So I put a list of examples in the notes. Notes aren't mine. But if you want to get more practice, I suggest looking up maybe udbit.com. They have a Java section that's really good.
What did that say?
And what was I gonna say?
Something like
Oh,
that.
W2 School. They also have a good job too.
Forgot.
So that's your example.
Then you have class.
W2 school.
So now we're going to get into loops. So loops can execute a block of code until a specification or a specific loop. So for example, here's a good example. Actually, wait. Here's the setup for what we call a while loop. And it's very similar to an if statement, where you see if condition. An if statement only runs once, while the while loop runs continually until the condition is false. So loops can make things more readable. They can also reduce the amount of code you have to write. And loops generally are just a way to keep repeating code outputs numbers from 0 to 5. Or yeah, from 0 to 5. So this loop runs over and over again until I is greater than or equal to 5. There goes 0, 1, 2, 3. So kind of what happens is kind of the system. So I is made. Then is I less than 5? Yes, it is, right? So that means the code is going to run. And it's going to print out I, then increment I by 1, go back up, check if I is less than 5 again, which is now 1. And then keep on running until I is greater than equal to 5. That kind of makes sense?
What?
Not moving around.
Yeah, Kevin, are you?
So one variation of this while loop is called the do while loop. And with a while loop, so with a while loop, this piece of code runs as long as the condition is true. With the do while loop, it does the exact same thing. It still runs until the condition is true, while the condition is true. But this runs once no matter whether it's true or false. So here's a good example. So what happens here is, let's say if I put -1 right here. 0 is greater than -1. This condition is false. Okay? But what a do while loop does is no matter whether the condition is false or true, this portion of the code runs once. Okay? So this portion will output 0 because system.out.println in I, which is greater than 0. Increment I by 1, and this will be the output. But if I change this to 5, this portion of the code will continually run just like a normal while loop. So we start at 0, print 0, increment I by 1, now I is 1. 1 is less than 5, and blah, 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 C4, and then that's kind of what happens. So do while loop is essentially the same thing as a while loop. Runs the same amount of code as long as the condition is true. But with a do while loop, it automatically does at least one repetition of the code. Another keyword is iteration. Basically repetition. Okay. So this guarantees one iteration, one repetition, while the while loop doesn't guarantee it. So with while loops, a lot of the times you don't know how long it's going to run. And it's going to keep on running until infinity, until you tell it not to. Do while loops guarantee one iteration, but same idea. You don't know how long it's going to run. With a for loop, this is when we know how many iterations we want, how many repetitions we want. So this is what a for loop looks like. So a for loop consists of 3 main statements. Okay? Statement 1, statement 2, and statement 3. So statement 1 is executed one time. It's only going to be used once. And then statement 2 is the condition. So as long as statement 2 is true, it's going to keep on running, just like a while loop. And then statement 3 is executed every single time after the code block is run. So after all this code is run, it's going to go to statement 3 and do whatever's in there. So here's a good example. So this is exactly the same thing as the earlier while loop. It just prints out 0, 1, 2, 3, 4, 5, or 3, 4. What happens here is, first it does the first statement. This first statement only runs once. So it creates I. Right? Then you check the condition. Is 0 or I less than 5? Yes, it's going to run. That means the code's going to run. Whatever code you have here, example. That I. And then after the code's done, it's going to increment it. Right? Now I is going to be equal to 1. And it's the exact same thing as the earlier while loop. So 0, 1, 2. So for loops are great because they can tell you how many times, or usually they're used to, if you know how many iterations or repetitions are to use. If I want to repeat this code 6 times, I can just change I to 6. Or I less than 6. Guarantee that. And this statement runs every single time as long as the code runs. So once I finish this code, it goes to the statement 3 and then uses that. Or executes that statement. So remember, statement 1 only happens once at the very beginning. Statement 2 is the condition. As long as this condition is true, it's going to keep on running. And statement 3 runs every time after the code is done. So now we're going to introduce this thing called break. Okay. So when a for loop encounters a break, it automatically ends the for loop. It just ends the whole thing. Okay. So here, so our break statement runs if I is equal to 4. Okay. So let's say let's just do the iteration. I start at 0, check it, my output 0, and I increment I by 1. I is now 1 because I incremented it. And is it 4? No, let's skip it. Output 1. And once it reaches 4, so now I is 4, since this condition is fulfilled, that means the if statement stuff inside of it runs, it breaks the for loop and it ends. So what happens when you encounter a for loop? It ends the for loop completely. The rest of the code is never run. Got it? Yeah. So another idea would be continue. And so this code right here, what it does is it outputs numbers 1 through 10, but it skips the number 4. Okay. So it skips the number 4. What continue does is once it encounters the line continue, skips the for loop and it goes to the next iteration and goes to run to statement 3. So I start with 0 and then I print blah blah blah. Once I equals to 4, continue is like reached. And it goes to statement 3, increases I by 1 without outputting it. So this segment of code, this segment of code prints numbers 0 through 10, but skips number 4. Cool. So yeah, I went over this last time, but I want to go in more detail because I think it's pretty important. But this is an array. So arrays are groups of data. Right? They're able to store multiple values within a single variable. And here's an example.
I see umbrella, or circle, or moon, or bracelet, or clock. I see blueberry.
So one thing you notice with arrays is that they have these square brackets.
Soccer ball.
Okay? Square brackets are usually only towards arrays. Got it? So in this case, this is a group of strings, and it's called cars. This is the name of the variable. It can be named anything. It can be named A or whatever. In this case, it's going to be called cars. Okay? So in order to make an array, we can use it with a curly brace and input the values manually. I can say Volvo, BMW, and Ford. So with an array, you can store a number of variables. So in this case, I store Volvo, BMW. And one thing to note is that arrays have a fixed size. So in this case, this array has 3 strings. Notice how strings are in double quotes. Strings always are double quotes. And I can't increase the size of the array or decrease the size of the array. It's possible. So arrays can be also made like this as well. And what this does is it creates an array with 3 values. In this case, they're empty. And you notice the new keyword, every time you see new is you're making a new object. Okay? Not a primitive data type like integer or boolean. But whenever you see new, it's usually referred to a non-primitive or an object. So in this case, cars is made with 3 empty strings. This number refers to the size of the array, and strings can also be replaced with integer or whatever data type you guys. Yeah, I can put double in there too. And so if I wanted to create an array of integers, I can simply just write like this. One thing to note about arrays is they're also zero-based index. So remember how in strings, they start on 0 rather than 1? Arrays start the same way too. 10 has an index of 0. 20 has an index of 1. 32, 4, 30. Each has its own index, its own kind of address, its own kind of path. So there are 2 things that you can usually do with arrays: access and mutation. So let's say I wanted to grab the 20 from this array. What I can do is I can just say the name of the array, which is A, square bracket, and I guess 1, and the index. And what this would do is I would grab the number 20 out of this array, because 20 is at index 1. Got it? So what if I wanted to grab 30? What would I have to say? 2. So this is going to be the index of where you want to go, or where you want to grab from. If I want to grab 40, I'll grab 3. If I want to grab 10, I'll put 0. So one thing you can also do is you can also change your values to it. In order to do that, so let's say I wanted to change the value 20 to 50, right? So 20 lives at the index 1, and I can just simply change it like this. So if this was like a normal variable, like int x is 20, I can change this to 50 by just saying x equals to 50. Right? This is essentially the same thing. Also, like strings, you can also get the length of the array. So this array has 4 elements. Got it? So in order to grab the length of the array, you can just say whatever the name is, dot length. One thing to note is that length does not have any parentheses. No parentheses at all. So let's say I want to access every single element in the array. Now I could just blindly just A0, A1, A2, and that would take forever if I had like 1,000 of them. Okay. What I could do is use a for loop. Since I know the amount of elements inside the array through a.length, I can use a for loop.
It was like on the ground. Oh, okay. Oh, I have to read it.
This one, so what it does is, in order to access the element, I grab the array name and whatever index it lives in. Right? Maybe 0. Instead of manually putting A0, A1, blah, 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 I can just do that in a for loop and then change whatever this number is, I. So in a for loop, I changes throughout every time you run it, right? So I starts at a 0. After the code is done, it goes to statement 3, runs whatever's in it. In this case, it increases I by 1, and then I becomes 1, and then this way, it accesses every single element in the array. So if I did system.out.print ln. This will print out 10, then 20, then 30, okay. Goes through every single number in the array, and it prints out because so one thing you'll probably encounter is called a multi-dimensional array. So this array has one dimension. What if I want to make a group of numbers in 2D? So a group of numbers in 2D is also known as a matrix. If I had 1, 2, 3, 4, 5, 6, 7, 8. This is a matrix. It's a 3 by 3 matrix with 3 rows and 3 columns. Got it? So 3 rows, 3 columns. All right. So multi-dimensional means I can use 2D, and that means there's a length and a width. One-dimensional is just length. So what I can do is, if I want to create a multi-dimensional array, I can do it like this. rows and all columns. Now make sure when you're coding this out, you put your rows first, then your columns. Got it? If I wanted to so I can also make this into an array. And with this, I have an array of an array. So inside each index of an array is another index of each index. Got it? That's kind of how two-dimensional arrays work. And in order to access an element, I give a name, the row number I want. So the row number I want. And then let's say I want to access 7. I can do row 1, and column 2. Yeah. So you do your rows first, then your columns. No, these are indexes. That's kind of how it's structured. Okay, so finally we'll do Java file input. This is something you probably don't know. So in order to access files, what we need to use is a file, or a file variable. So just like string, file is also an object. So how file input works is you get the name of your file, and then you set up like this counting. File as equals new file, and you notice it's an object because it has new in it. And another thing is f meaning whatever name you want it to be. But yeah, so this file is going to refer to whatever text.txt or like any file. Okay. Sometimes in URL format we'll use .bat, just like a Microsoft thing. Sometimes we'll use txt, sometimes we'll use .in. But whatever extension you use is fine. So you make a file. So let's say I'm grabbing from text.txt. And so what I can do is if I want to scan through this file, I can make my scanner. Let's see. New. And instead of putting system.in, I can just put whatever file I want. And what's going to happen here is it's going to read whatever's in the file. It's pretty cool. It's going to be used in competitions a lot, and you guys will probably that's kind of how it works. One thing you have to know is in your main, in your colon static void main, at the very end, right here, you're going to have to write these words. Throws IO exception. Okay. It's kind of weird, but it's actually very important. So when dealing with files, or dealing with any error for that matter, Java is very specific actually, Java likes to deal with worst case scenarios. And this IO, so if you just do this without throws, IOs, exception, right, it's going to give you an error. And the reason why is because what if you put like a file that doesn't lead to anywhere? And if you scan a file that has nothing in it, it's going to give you an error. And it's a little complicated, but make sure if you're using or scanning a file, throws IO exception. Got it? So Java throws an IO error in the possibility that there's an incorrect file. Give me a time.
3:36.
36. Well, kind of all I have today. I want to learn recursion. Well, this is pretty important. If you want to do any competitions, you should know how to use file input output. Oh, should I do output? Actually, no, they usually do output.
Hey, lock up. I gotta get going. I got my meeting for Monday. Doctor got pushed today, so
Alright.
I'll see y'all tomorrow. Bye. Bye. Yeah, I'm good.
Bye, sir.
Alright. Yeah, so that's the file item. It's not that much. It's not really that hard. If I were to do some more research on printing inside files, I think that'll be it for today. Don't really have anything more to find. But next week we'll start more complicated topics.